Good afternoon. Welcome Towards a Holistic Approach in Building Intelligence to Fight Crimeware by Dia Majoub, Misha Sakali, and Thomas Matthew. We are in Mandalay, BCD. If that's not where you intend to be, then you need to move along. But before we begin, a few brief notes. Stop by the business hall located at Bayside AB during the day and for the welcome reception tonight at 17:30. Also, Black Hat Arsenal is on the Palm Foyer on level 3, and the Pawnee Awards are tonight here in this room at 18:30. Thanks for putting your phone on vibrate. It makes it easier for the rest of us to ignore the ringing while you wait for your voicemail to pick up. And with that, gentlemen, take it away.
Well, good afternoon, everyone. It's great to be here. And our talk today is about research we conducted OpenDNS and Intel 471 in having like a holistic approach to fighting crimeware. So who am I? I'm Dia Majoub. I'm the technical leader at... Weird. Sorry for that. Okay, so I've been doing security research on networks and algorithms for a while. I spoke here at Black Hat before, and then I work with my team to build detection systems at scale.
Hello, everyone. My name is Mikhailo Sakali, and I'm a Cyber Research Unit Lead at Intel 471. My team is tasked with proactively monitoring, tracking, and attributing predominantly Russian-speaking actors in the Russian-speaking underground. My educational background is Master of Laws degree, and previously I served at various investigative positions at the Security Service of Ukraine.
My name is Thomas Matthew. I'm a researcher at OpenDNS, and my focus is on machine learning algorithms, in particular an emphasis on graph analytics and time series analysis.
So let's discuss the outline of today's talk. So our focus is cybercrime, like we said. We'll talk a little bit about the different offerings we see in the underground, so products, services, and goods. And then we'll focus mainly on bulletproof hosting providers, because those are like a key enabler of most of the operations. And then we'll propose like different ways to classify these BPH providers. But most importantly, we'll discuss the different data sources we use for that. So we propose a network-centric view and then an actor-centric view. So what is cybercrime? In the context of the talk, let's define cybercrime as any criminal operation conducted online whose main purpose is financial gain. And if we observe it in the underground forums and marketplaces, we will see it kind of coming in three different offerings. So first, we'll see products, namely your malware, rats, brute forcing tools, banking trojans, exploits being traded. And then you have the services, and these are like very important because they allow you to deploy your campaigns at scale. And we're talking here about DDoS, the exploit kits, the ransomware as a service. And in this talk, we are interested in the bulletproof hosting infrastructures. And then finally, you have goods, or what we call them like final products, because these are those commodities you can consume right away. So we're talking about database dumps, stolen credit card dumps, and fulls. So if we're talking about bulletproof hosting providers, we want to approach it first from the network perspective. So for this, we deal with DNS, IP, BGP, whois, malware samples, and SSL data. And for that, we track specific attacks here because they give us a direct link into the BPH infrastructure. So typically, we're looking mostly at exploit kits, ransomware, malware C2s, and phishing domains. And then when you pivot around those domains to the IPs, we're not interested in the discrete IPs, but in the IP space that is being leveraged for these operations. So we do like some IP space monitoring. We can also track the BGP announcements across ASNs, and we found like different evasion techniques used by these operators. You could also study the upstream and downstream relationships between ASNs, and for that you can build a graph and do all kinds of graph mining on it. And then you could also use pivoting around whois data points to find like other badness from an initial seed. It's not the focus of this talk, but obviously you could do malware analysis and start your research from that side. But the novelty of the stock is that we use the data that is coming from an SSL worldwide scan to do this type of investigation.
So why should we care about SSL, and like what is SSL? SSL is a mechanism to encrypt and authenticate communications over the internet. And so it transforms HTTP into HTTPS. But the bigger question is, what importance does SSL have to a security practitioner or researcher? So traditionally, you see big banks and large commercial hosting providers provide SSL communications to their clients in order to guarantee security. But as Misha and Dia will show, as bulletproof hosting providers have increased in sophistication, they have used SSL as a means to encrypt traffic between their own providers and guarantee malware authors have some level of sophistication and security. So as a result, we can now think of SSL as a very valuable fingerprint in understanding various IP ranges and domains, and it can help an analyst identify similarly linked IPs and domains with one another. We believe this is a unique method of using SSL information. So SSL consists of a 9-step process, but we're only really interested in 4 of them. The first is a request from the sender to the server, and then the server responds by sending out an X509 certificate. This certificate is incredibly important because it acts as the mechanism of authentication and further encryption channels. And this is done when the encryption session is chosen and then a full session is initialized. So this diagram right here shows us an example of a X509 certificate. It consists of 2 parts, a data section and then a signature section. For us, we're going to be focusing primarily on the data section because it contains valuable information regarding the issuer and the subject. Who is the issuer? The issuer is the individual who has created the certificate. And as such, the issuer is the person who also verifies the authenticity of the subject. So for example, a Bank of America X509 certificate is usually verified by VeriSign or Komodo. And then there's somebody that's called the subject. That's the person who the certificate belongs to. So in this case, the information for who and whom the certificate belongs is found in the common name field of the certificate. And by analyzing common names, we can identify groups of individuals who share the same certificate across ranges of IPs. We can also use further information like the organization and organization unit name fields to get a better understanding of the network of the subject. Now, we only care about 2 different types of certificates in today's talk, self-signed certificates and valid certificates. Self-signed certificates are certificates that are issued and verified by oneself. So there's no other hierarchical chain of trust. It's basically anybody creates a self-signed certificate and throws it out in the wild. The second is a valid certificate, and these are certificates that are verified through a trust process involving a certificate authority or intermediate authorities. And so when you connect to a website that has a verified trust, the server will send you the entire list of all certificates tied. And this is valuable because it allows us to reconstruct the trust model as well as the network relationships between various SSL certificates.
Now we move to the actor-centric view, and for that, Misha will discuss the different entry points they use.
Yes, so what's just Dia and Thomas talking about is kind of a traditional approach to research of and analysis of cybercrime actors and their activity. We at Intel 471 are trying to supplement this by alternative approach. So we are working not from the badness to actors, but vice versa. We're trying to tie specific actors to indicators. And we are doing this in several steps, let's go this way. And we always start with infiltrating and maintaining presence at the underground marketplaces and cybercrime forums. Those places, they can be seen as kind of places where actors meet and they trade their goods, services, their products, and that's the places where they build out their reputations, where they get and leave feedback for one another. So that's kind of starting point for us to single out specific actors. When this is done, we are trying to do the real magic, like to directly engage specific actors. And this is kind of most interesting and difficult part, actually, because you have to have people just in the field with knowledge of cultural diversities and language capabilities of actors, and they have to maintain their personas online in the underground forums. So that's what we are doing in this field. And what is specifically important for bulletproof hosting provider monitoring and research is the third step is the purchase of services, because only this approach, it can give you specific data on the indicators of bulletproof hosting providers like IP addresses, domain names, networks, autonomous systems. Yes.
So given the two views that we discussed, now let's propose a taxonomy for classifying these bulletproof hosting providers. So we start with the actor view, in fact.
Yes, so this is a kind of in-house taxonomy we use at Intel 471, so it's not kind of a universal approach. So we are trying to classify bulletproof hosters into 3 tiers, and the first tier is considered to me to be the most sophisticated one. And to be able to do this, we are trying to single out some like specifications or marking system for these bulletproof hosting providers. And they are like the following. First of all, we're trying to assess for how long the actor was active in the underground. What is his reputation? And that can be done by researching his links with other reputable actors, for example, or his involvement into some high-profile malware campaigns, or for example, if he is maintaining infrastructure of high technical complexity. So for example, for tier 1 providers, we have seen bulletproof hosters who are trying to mimic the legit hosting services. So they are running their own data centers with physical servers, with teams of admins and support staff. And it's just like any other but legit service, but found in the underground. And another point here is for some, the most high-profile bulletproof hosters, we even see the like relationships to upper entities, like for example, links to ISPs, legal ISPs, or even governmental entities. We've seen that in some Eastern European countries where the actors kind of receive protection even from government officials.
The network view into this classification will focus on different points that we'll discuss here. So we observed over time that a lot of these bulletproof hosting providers, they register their businesses in offshore jurisdictions. They're talking about Caribbean countries like Anguilla, Belize, Dominica, Panama, or Seychelles in the Indian Ocean. We also saw them operating leaf ASNs. What we mean by that is that it will be an ASN only having upstream providers and no one is relying on them in the downstream, which means you could set shop, deliver your malware campaign, and then you just kind of shut it down and go somewhere else. So no one is dependent on you for advertising their prefixes. And so that makes you kind of a nomad or a mobile kind of operation. We also saw a lot of these providers, they will offer to accept anonymous payment methods like Bitcoin and Perfect Money. And then another way to classify them is that we find some of them will be offering hosting based on botnets, and others will be using dedicated hosting kind of servers. And then finally, we saw some of them are operating their own data centers or ASNs. Some of them are using other third-party servers, and sometimes they use like a hybrid model. Now let's take an example of a botnet-based bulletproof operation. So in here we'll talk about the ZBot FastFlux proxy network. This one is quite known. We've covered it for the past few years at Black Hat 2014 at BotConf. Other researchers and vendors are kind of having it under the radar. So I will not dwell on the way to catch it from a DNS perspective. I'll just go over a few features that are kind of interesting. So the ZBot FastFlex proxy network, it's in fact, the way you catch it is you catch the domains from it. They are FastFlux with a TTL of 150 seconds. Most of the bots are in Ukraine and Russia, and it's offering some kind of a reverse proxy infrastructure for all kinds of malware. So in the beginning, it was delivering Zeus, Kins, Ice9, then a variety of other malware like Timba, Rovnik, Sneakers, and some Pony panels. We've also seen it recently being used for phishing campaigns. And interestingly, a lot of the credit card dump shops, they've been hosting their servers, or at least delivering their content via this CDN-like infrastructure. Now, in fall of 2015, the operators behind it kind of changed their technical setup. So they moved from a fixed 150 seconds as TTL to a random value in the range 129, 150 seconds. And we just did like a simple data analysis experiment here. We took like a large sample of these domains. We resolved them either via passive DNS or active probing. And then we kind of plotted the distribution of occurrences of these TTLs in this like resolution data. And we can see that they occur equally likely across the population. The important aspect about this botnet, in fact, is the SSL part. In fact, we found out, I would say a year and a half ago or 2 years, that most of the bots, or a big chunk of the bots, are hosting SSL certs. And this allowed us to do a different type of analysis on this botnet, where sometimes passive DNS or malware analysis cannot see that picture. And for that, we adopt like a couple methods, both passive and active. So for active probing, for instance, you can start with a seed list of domains or IPs, and you go and just like probe them for the search. So if you could do it manually with OpenSSL command, and you grab the X509 cert from port 443, once you get that, you just transform the PEM into a DR file, and then you calculate the SHA of the X509 cert. And then given that SHA, you can then search your SSL database that Thomas kind of introduced earlier, and that he will cover later. And this way you are able to do different types of associations, like IPs to SHAs, and from SHAs you can go to other entities, whether domains, IPs, or other IOCs. And this was very efficient, in fact, to uncover things that the classical approaches were not able to see. The other method is the mining in passive mode. So we could also pivot around the common names in the SSL content. So in this case, we took an example of FastFlex domains on this botnet, and then we searched for hits on the common names in our big database. And interestingly, we found at least 12 hits. These are malicious SHAs or certs that are hosted on the botnet at some point in time that were not kind of flagged or discovered at the time of the discovery. Thomas mentioned earlier that the two types of certs we see are the self-signed and the trusted ones. So in this case, for the self-signed, in fact, one of the certs was already flagged by abuse.ch SSLBL dataset, and it's been involved in the Redims malware communication. We also saw a lot of self-signed that are specific to some routing devices, like Ubiquiti is very prevalent here. And finally, the trusted ones, in fact, are delivered or issued by known entities like Comodo, and they have common names that are I would say legit in the sense of they are registered domains, but they are part of the botnet. And they were present on a lot of the IPs of this botnet. So this was an example of a botnet-based bulletproof operation. Now we will talk about different use cases of dedicated hosting operations. And we'll start with Abdallah.
Yes, so we will discuss several examples of bulletproof hosted providers at each tier we have in our classification. And Abdallah, that's the moniker that the actor was known several years ago, and now he is known under the alternative monikers, the W host and web host. He is considered to be one of the pioneers, actually, of bulletproof hosting business, at least at Russian-speaking underground. His roots can be traced back to the days of RBN. That's like 2002. And RBN is the Russian business network, which at that time was notorious and was like the first really big and sophisticated infrastructure that provided services to every kind of badness, from phishing pages to malware to porn and all this stuff. And this actor is actually one of the most highly reputable in the underground. For example, he is the moderator of hosting section of the main, or let's say the only actually remaining high-profile and vetted cybercrime forum, which is known as Maza or Mazafaka. Speaking about specific examples of his involvement into the major badness, we can name, for example, one of the blacks, and black is the how the Russian-speaking actors call the complaint which is filed by one actor against another. So one of such blacks, it was filed by Abdullah against one of the reputable members of the Maza forum. And while researching and analyzing this black, we came to conclusion that actor that Abdullah was addressing to, he is actually Slavic. So that's the actor who is known to be behind the Zeus, Game Over Zeus Trojan. And in his black, Abdullah alleged that he was not paid for 2 months of his service, and the debt was $30,000 just in 2 months. So this veraciously shows that Abdullah was involved in Game Over Zeus infrastructure and was providing a huge infrastructure that costed like $15,000 monthly to the author and vendor of Zeus. That was already discussed, and yeah, this screenshot, for example, shows that Abdullah is actually bragging with his reputation in the underground, and he says that his service will never be found by any security or law enforcement. And
so from a network perspective, to follow on Misha, in fact, we worked with them, and we now know that Abdullah was advertising that he's operating this AS59580 with a couple ranges on IPv4 and one on IPv6, and he's claiming that this this ASN is in Iran. We believe it's a marketing ploy. In fact, we use like a proprietary in-house method to verify that, and we got like some strong technical indication that the ASN is in the Russian-Ukrainian region. Now let's move to the next tier 1 BPH provider, MaxiDead.
Yes, this is another example of very highly reputable actors providing this type of services. And this particular actor, he can be traced back to 2008. And he was actively advertising his services in the underground and cybercrime forums since at least 2011. So at that time, he was present at most of the mid to high level forums. In recent years, we haven't seen him being active at the forum, at least since summer 2015. But he is still maintaining some kind of front companies, so like public companies, and one of them is MaxiDead.com. And this entity, it's still highly discussed between other reputable actors across the Russian language underground. We also, through our research, we also proved that MaxiDead was actually one of the original members of Game Over Zeus crew. And he was actually the one who was providing the whole infrastructure for the team. And for example, he was running the Jabber servers that was used by the team members to correlate their actions. More recent research shows that he was closely cooperated with actors behind the Kali House botnet.
So looking at the public presence of MaxiDead that Misha mentioned, the MaxiDead.com, on that website, in fact, you will find that they're offering servers in up to 83 countries, mostly in offshore jurisdictions with various abuse policies to allow for rogue and toxic content. The other interesting investigation we conducted is that we found that MaxiDead is also operating their own ASNs, and they're registered offshore in Dominica, one of the Caribbean islands. Now, this animation here will show how we got into this discovery of the 4 ASNs operated by MaxiDead. So initially, we were actually looking at the ZBot FastFlex proxy networks. As we said, we were looking at domains, IPs, and also SSLs. We came across an SSL cert that was hosted on some of the bot IPs, and the common name of that cert was intaccdn.am, just a domain that was registered. And it resolved to this IP 185.134.254, which happens to be part of the /22. That /22 is registered by this entity called Syndicate Group. Now, when we dive deeper, we find that Syndicate Group has registered a couple ASNs. One is located, actually both of them are located in Lithuania. The first one is Silk AS, and it has one range that is associated with MaxiDead label. And the second one is Syndicate AS, which is also advertising a range under like ohs4u.net. Now, we dig deeper and we find that the handle that was used to register Silk AS was Antonio Jordan. This entity also registered another ASN, MaxNet AS203.128. And it's advertising a range that is also part of that bigger /22 we mentioned earlier. This ASN happens to be in Moldova. And finally, we look at Syndicate AS, and Pavel Bandarik happens to be the handle. And this guy also registered another ASN, which is actively, it's active at the moment. In fact, all of these 4 ASNs were registered during the same time period last November of 2015. And most of them were advertising subsets of that /22 we're talking about. And finally, Host Shield, that we see at the bottom, the active one at the moment, is involved in both toxic content that is being hosted. So you're talking about other BPH hosting providers like offshore.la, toxic content like malware, porn, and gambling, and those different things. But also it's involved in originating malicious traffic, SSH brute forcing, and DDoS attacks. So here we have to point out that when you study these BPH providers from the IP space perspective, don't just look at the hosting stuff, also look at what they are originating from their IP space.
So here's another example, and we put him in tier 2 of the R classification because this actor is believed to rent infrastructure from other legal hosting providers, and unlike those we mentioned earlier, they are actually running their physical data centers in Eastern Europe. And this actor, known as Althost and also under monikers Sidvicious and Bullet, he has been active in the underground since 2011, and he was very highly prized by fellow members of cybercrime community for the diversity of his services, for reliability, and for the prices he offered him. And he also, like those we just discussed earlier, he was also maintaining presence at high-profile to mid-profile cybercrime forums, which are Maza and the now defunct VCC. And he was providing a number of services, and among them was also a host-based FastFlux service. Through our research, we were able to gain access to the client control panel of his FastFlux infrastructure. Here's, for example, a screenshot where you can see it's pretty basic, but his client can actually link his malicious domain and the IP address, the backend IP address, to the FastFlux infrastructure and hide it between it. And here you can also see that in the menu that the Althost was also utilizing API, which enabled actors to do that in like automatic manner in no time. And through our research, we were able to tie this particular actor to a number of badness. And for example, one of the complaints we've seen in the underground, it was from the author and vendor of Cerberus ransomware. And that complaint was actually deleted just in minutes after it was published, but we managed to capture this. And it provided insight that the actor behind the Cerber ransomware, he was using services by AltHost. Besides this, the AltHost is also known to host any kind of other badness like dump shops, dating scams, phishing pages, and all of this stuff. And there is also a notorious Russian language cybercrime forum known in Russian as VVH or wwh.mu, and it was also for a very long time hosted by this actor. So these are the offerings from the AltHost. So it was just any types of service you will find in normal legit hosting service provider, including SSL certificates and even administration of services for his clients. But AltHost, despite he was active for several years, he disappeared from the underground just a month ago, in the beginning of July this year. The exact reason is unknown, but we were able to get intel that the actor is actually trying to resurrect in the underground under alternative monikers. So he is expected to be somewhere online and operating under another moniker. So it's still an ongoing research here. What's interesting that just a few days after he disappeared from the underground, his place was taken over by several of those bulletproof hosting providers we just discussed, for example, Abdullah, and one that we're going to discuss next, that is SoSuite. So just actors are trying to fill this gap just in several days after one of their competitors vanished.
So what Misha mentioned is what they saw from the forums and the actor perspective. In fact, from our side, the DNS and IP telemetry, we saw an interesting spike in traffic to the AltHost panel and then to some of the other competitors that Misha mentioned. We can see screenshots here. So on the left, you see the spike in traffic to the one of the AltHost panels. Probably people are kind of worried or freaking out about what's happening. The other one on the right is the maxidead.com public website. So possibly it's also people visiting Maxidead to see if they can find any alternatives. It could be also coincidence, but we're just like showing you these interesting patterns. At the same time, there was also a spike to hostshield.net. This is one of those ASNs we mentioned that is part of the Maxidead ring. And then finally, we see dataflow.su. This is another BPH, not part of the Maxidead, that Misha will cover later, but they also saw a spike in traffic during that very short time period. Now, what we would like to kind of emphasize here is that combining these two views, the actor and the network, you can get like a better understanding of what's happening. For example, in the Maxidead case, from the forums, and then we found those 4 ASNs operated by Syndicate Group. And then in this case, you see the chatter in the forums, and then you observe it from the DNS IP telemetry on a world scale.
So this is the guy that I was just referring to, who was trying to fill the gap after AltHost has vanished. So he is known in the underground under the moniker SoSuite, and he is running front entities known as Dataflow and formerly the randomservers.com. This actor has been also active for like 7 years, but he was active in many types of cybercrime. And the Bulletproof Hoster service is kind of one of his new services, and it has been offered since 2014. And the actor is also present and active in a number of forums, but mainly the low-level and mid-level ones, like Exploit.in and DamageLab and AntiChat. Through our research, what we also know for sure that this particular actor, he is operating his infrastructure in one of Eastern European countries, and he was actually quite frank in communication with his fellow actors in the underground. So he was like admitting the app link providers he was using to and the specific places he is keeping his servers at. And for this actor, and actually for those we just discussed, we were able to tie those monikers to specific people in different countries. But of course, we are not going to disclose it here publicly, but this is the what we're doing on the daily basis.
One thing to mention here, this AS we mentioned here, it's again a Leaf ASN that feature we observed earlier, and it's again registered offshore. So you consistently find these two patterns from the network perspective for anything that Misha's team is investigating.
So about examples of the badnesses he is involved at, is that he is not only running the bulletproof hosting. He is, for example, known to be the author and the vendor of the notorious DDoS bot known as Overflow bot. And he is not only selling these, but he is providing the DDoS services in the underground. We did also mention to link him to Rediment ransomware, which is known as the CryptoLocker and ransomware as a service platform. And that was actually interesting that the official vendor of Rediment in the underground, he was specifically recommending his clients to use just 2 bulletproof hosters. SoSuite was the one, and Abdallah that we mentioned earlier, he was another. So these 2 actors, they were kind of official providers of infrastructure to the Rediment clients, and they were offering like all-in-one solution for Rediment users, just VPS and VDS complemented by specially crafted domain names, so it just enable actors to get Rediment up and running just in minutes. Besides of this, of course, he is known to host many other stuff like dump shops and exploit kits and many other badness.
So the next provider we're going to cover, we've seen this one for a while from the network perspective. So this guy is called Xserver AS48031. It's again a Leaf ASN registered in Belize, an offshore jurisdiction, with presence in Ukraine and Russia when you look at the IP space. It's been involved in a lot of badness over the years. The interesting feature about it is that it's been fluxing on and off of the BGP routing tables, which means it will advertise its prefixes and then it will stop. So the prefixes now, they go to its upstream, who will be taking care of them, and then the guy will come back. And we believe it's kind of an evasive method that they use. Now, in terms of the public-facing companies Xserver operates, they have a few different websites. So you could buy from them via the xserver.ua website. You could also go to paylicense.net or layershift.ru. These 2 domains actually point to the same front website. And you find again that these 2 entities are registered in Belize, and they have, in fact, their own ASN. So PayLicense also owns their own ASN. So we find here that mixed a model where you have your own infrastructure and then you get IP space from another entity. And finally, there's another one, Just Host in UA. This provider, in fact, they're registered in Dominica, another offshore jurisdiction, and then they operate servers from Xserver data center. The final provider that is using Xserver is BQ Host. It's advertised in the forums, and we found that it's in fact using the IP space of Xserver.
Yeah, just a few words on this. What's interesting about Xserver that he is not visible in the underground, but as this example shows with BQ Host, he is known to be used by other bulletproof hosting providers, and our intel shows that he is actually co-locating servers, physically co-locating servers for many of those that were named here and other actors. And yeah, sure.
This one here, in fact, is related more to the SSL investigation that Thomas will discuss in a bit. So this is an offshore racks company. It's called Offshore Racks, and it's they have their own ASN, AS52469. It's again a Leaf ASN registered in Panama, one of those nice offshore jurisdictions. And it's hosting all kinds of badness. But most interestingly, we were able to use it for a nice use case with SSL investigation.
So I'm pretty sure most of us have had problems investigating domains hidden behind Cloudflare's IPs. And so there was a forum called darkmoney.cc, which hid behind Cloudflare. But we realized that if we searched our SSL X509 database, we came up with a match for a certain common name, which was darkmoney.cc. And if we then matched that SSL hash with our IP to hash table, we realized that we could identify its most recent IP mapping, which was on June 27th. And so once we found the IP mapping, we could then go to that IP and just do a curl and verify that the content hosted on that domain was identical to what other people were seeing. So it's a useful tool for unmasking domains hiding behind Cloudflare. Okay. So we've kind of danced around this issue, but both Misha and Dia have talked a lot about kind of how we've been able to use SSL to identify malicious domains. But the question is, where are we getting this data and what is the data? So the data that we're working with comes from Scans.io, and that's over 800 gigabytes of data for the last 3 years. And in order then to index and store this data, we needed a large database or databases that could handle it. And so the three components that we focused on were scalability, speed, and flexibility. And we needed two different databases because we're dealing with two different types of data formats. One is an X509 certificate, and the second is what we call a correspondence relation, an IP to an SSL mapping. And X509 certificates don't store well in most relational database models because they create overly sparse tables. And for a key value store, we realized that we wanted to use something like HBase. So as a result, we came up with this data platform architecture where we have Investigate at the very top, which is a tool that allows an analyst to search through DNS data and SSL data. And it talks to an API endpoint, which is connected to an Elasticsearch cluster and an HBase cluster. Oh, okay. And what is HBase? HBase, you can think of it as a giant dictionary. It's a perfect key value store for highly stratified data types. And it only has two atomic operations, though. There's a get operation and a scan operation. A get operation is when you give it a certain key, and then it returns all the values associated with that key. And then a scan operation is when you have a certain range of keys that you're interested in kind of getting all of their corresponding values. But the challenge is when you're dealing with only two atomic operations, it's very difficult to link together very complicated searches. Like, what are all of the SSL certificates found in China that are also shared in Mexican IP space? So it's difficult to kind of do complex combinations on HBase. As a result, you need to design your tables pretty carefully. And so table design also needs to take into account the backend infrastructure or the physical infrastructure behind HBase. So there are four major components. There's an HBase master, which kind of monitors the entirety of the cluster. And then there's a region server and a client server, and then a name and data node data node server, which are connected. But the most important part is the region server, because the region server handles the automatic sharding or splitting of the tables. And as we're going to come to see, this can pose a really big problem when you're dealing with very large data sizes and imbalanced row keys. And so that then brings us to the question of what is a row key? The row key is kind of your equivalent of a primary key for people who are used to using a SQL-esque database. So you have a row key, and then you have what's called a column family. And a column family has individual pieces of data regarding that row key. But the row key is really the most important piece of information because you're dealing with a distributed system, your row key is going to be distributed across multiple machines. So you need to make sure that you're splitting your row key across multiple machines extremely efficiently so you can perform high performance scans. So what were the questions that we wanted to ask? The most simple question is, well, what are all the IPs associated with a given SHA? A slightly more complicated question could be, what are all the SSL certificates associated with the Mexican IP space in, say, the last 2 months? So we had to design a row key with this in mind. So we have three pieces of information. We have IP information, timestamp information, and then the SHA information. And so here we faced our first design trade-off. Do we have wide tables or deep tables? So I'll just use the images to help you guys understand. So what is a deep table? A deep table is when you include a lot of information in either the cell value or in the column family called and column qualifier values. So in this case, you have a row key, which is nothing more than a SHA and a timestamp. And then the information is stored individually as the various IPs corresponding with that SHA. A flat table would look something like this, where all of the information is kept in the row key, but there's no information in either the column family or in the cell. So why did we end up making the switch? It's because key distribution matters. When you're dealing with over 3 years of IP information and your data is a scan of the entire internet, certain SSL SHAs are more popular than others. So for example, when we're looking at Amazon.com, SHAs associated with Amazon.com don't range in, say, the hundreds or even the thousands. They range in the hundreds of thousands to close to the millions. So if we have a very deep table in which data is normalized, when you perform a get operation on an individual SSH SHA, you don't return just a couple of entries. You instead return a bulk. And this bulk can overload the region server and bring down the HBase cluster. As a result, we made the switch to a wider table, which allows us to perform high performance scans quickly over ranges of IPs or SHAs and return values. However, this leads to the trade-off where a lot of the post-processing has to be done by the client on the client side. But despite these trade-offs, we're able to do random reads below 0.4 seconds for a row size over 1 billion rows. So we were pretty happy with that. Elasticsearch is a lot easier to work with. It's just a basic document store. So we set up a cluster with 8 nodes and 70 gigabytes total. And then the only word of advice is don't dump the documents into Elasticsearch without writing a custom indexer. So in our case, we wrote an indexer that would only index subject and issuer information, in particular common names and organizational units, as well as the date of scan and the cert validity period. And that's what allows you then to pivot around certain expiring certificates or certificates that are about to expire in the near future. And all of this is powered at the back end by Lucene, which does the heavy indexing. So now.
Thanks, Thomas. So as a demo, we want to go over one example of the stuff on Zbot. So royaldumps.tw. I'll run the video here for you. So we took that dump shop and we typed it in to investigate our OpenDNS search platform. So you have it there. It happens to be on that fast flux, so we'll be seeing a lot of IPs at the bottom, ASNs and prefixes and IPs. That's your typical case of a domain hosted on or delivered by a fast flux. Then one of the IPs, in fact, has a bunch of SSL certs associated with it. At the bottom, you'll see all of the domains that are hosted on that IP. But then if you go back to that cert, you will see the content here. So the common name happens to be intaccdn.am, the one we explored earlier to find the syndicate group maxi-dead ring. So you can see like the interesting patterns here that you can follow the breadcrumbs from one operation that is botnet based to a dedicated hosting. This SHA is present on a ton of IPs here. Now we go back, there's a sample, a malware sample that was associated with that IP. So here we can pivot around the malware samples. You have a bunch of IOCs, also some artifacts at the bottom. And then finally, another interesting pattern is that you can go look at the co-occurring domain. So at the bottom here, we see try to swipe me. That's another dump shop. It's also on the FastFlux network. You can see here all of the IPs and prefixes and ASNs. And finally, from that try to swipe me, there's also Popeye. I kind of skipped it here. Let me go back. So Popeye happens to be at the bottom, right there. So we click on it, it co-occurred with those two previous domains, and then we find that it's also hosted on the FastFlux, and it shows the same pattern of high volume of IPs and prefixes. So the demo here is kind of showing how you can pivot from different data points, IPs, domains, SSL SHAs, common names, and malware samples to get like a better view of what's happening in your investigation. Now, as a conclusion, our proposal to you is that if you want to have the best kind of insight into the threats that are targeting you and be able to have the best opportunity to mitigate that, you'll have to have visibility into three main areas: your own network, the actors' infrastructure, and finally the underground marketplace. And by giving this talk, we try to kind of share with you our experience in kind of tackling these different views to have a better approach in fighting cybercrime. So that is all. Thanks again for your attention. We'll be happy to take questions.